Today we're tackling the 810-110 exam. We're doing a deep dive into 5 crucial questions on AI in the software development lifecycle. Let's get you ready to pass.
Yeah, let's jump right in.
So, right at the beginning of that lifecycle, say you're feeding stakeholder docs into an AI to find inconsistencies and draft user stories. Which phase is this? The options are implementation, maintenance, requirements, or testing.
Well, a lot of people taking this exam jump straight to the testing phase for this one.
Right, because you hear AI finding inconsistencies, and your brain just pictures a QA tester rigorously hunting for bugs.
Exactly. It's a really easy cognitive trap to fall into. But you have to remember, we haven't even built anything yet.
Oh, right, so we can't test it. Which means the correct phase is AI in requirements analysis.
Precisely. The AI is validating the plan itself. It's verifying structural logic before execution.
Like a structural engineer.
Yeah, like an engineer running the math on a blueprint before a single drop of concrete gets poured, which completely eliminates distractors like testing or maintenance, since those only happen after you build the product.
Okay, so the blueprint is solid, from figuring out what to build to actually starting the build. Let's say a team wants to scaffold a new microservice with AI. The options here are removing logic, generating structure, deployment scripts, or testing code.
This one is definitely tricky.
It is, because my gut reaction to the word scaffolding is to assume infrastructure, like setting up deployment scripts or CI/CD pipelines.
You and half the people taking the exam, honestly.
Yeah.
In physical construction, scaffolding is on the outside of a building, so you intuitively associate it with external tools.
Oh, that makes sense.
But in software design, the right answer is generating the initial structure.
Meaning it's not writing the final production logic, just the boilerplate.
Exactly. The AI is framing the house. It's putting up the wooden studs so developers can hang the drywall later.
The drywall being the custom business logic.
Yep. Which eliminates testing and removing logic.
So once the structure is built, how do we safely test it? We need to look at how generative AI supports the testing phase. The options are static analysis, user stories, synthetic test data, or automated docs.
Well, the obvious assumption here is static analysis, right?
Yeah.
Scanning syntax for errors.
Yeah, because it's an AI reading code.
Right. But I'd push back on that being a generative AI task. Traditional rule-based tools have done static analysis perfectly well for decades. The real superpower here is generating synthetic test data.
Ah, I see. Because testing edge cases with real user data is just a massive privacy nightmare.
Exactly. GenAI understands complex data relationships, so it can fabricate entirely fake but mathematically sound data sets.
Oh, wow.
It's like using crash test dummies instead of real humans. Do the exact same physical feedback without risking real lives, or in this case, user privacy. That eliminates docs and user stories.
The crash test dummy analogy is great. Let's pivot back from testing to AI generating code. What's it called when an AI creates a full Python API client from a description? Options are inline copilot, predictive logic, scaffolding, or refactoring.
The industry has basically conditioned us to call this an inline copilot.
Wait, isn't it all just AI writing code for you?
Not quite. It's a dangerous bias for the exam. There's a massive architectural difference between an inline copilot and actual code scaffolding from high-level prompts.
Okay, so code scaffolding is the answer.
Yes. An inline copilot operates on predictive logic, looking at the line you're typing and handing you a single click.
Just the next piece.
Right. But generating a full API client class from a description is like ordering a whole prefab wall. You aren't refactoring legacy code line by line. You're scaffolding an entirely new component from one prompt.
The prefab wall makes total sense. But what happens when that wall cracks? Question 5. You feed AI runtime error logs to get a root cause and a fix. Is this CI optimization, AI-assisted debugging, unit testing, or scaffolding?
People see error and fix and immediately think automated unit testing.
Which is a trap, because testing is just a pass or fail check, right?
Exactly. A unit test is driving a car through a basic state inspection. It tells you if the brakes work or fail. But AI-assisted debugging, which is the correct answer, is completely different.
Because it analyzes the context of the failure.
Yes. It's like handing a master mechanic the exact sound of an engine knock, along with the telemetry data, so they can diagnose the specific misfire, not just testing for a break, but resolving it.
Okay, we made it through the gauntlet. Now let's connect the dots before we wrap up.
For sure. The key to passing is understanding how these pieces interlock. We started with AI in requirements analysis.
Right.
Then we looked at AI-assisted code scaffolding. After that was generative AI for test data.
To keep things safe.
Exactly. Then we expanded the build through code scaffolding from high-level prompts, and finally we fixed the cracks with AI-assisted debugging.
Which completely reshapes the development pipeline. If AI handles the scaffolding, data, and debugging well, how long until a developer's only job is just writing perfect requirements?